Hello, Olathe West. This is the last of 3 videos going over the practice ACT from October. We're going to be doing question numbers 39 to 60. Okay, question again on these questions. On the left-hand side, I've got all the answer choices and then the percent that people chose, highlighting, of course, the correct answer. Now, this question says, given these two matrices, which of the following matrices is x times y? Well, let me first write this out. There's x, right? Because it's right here. And here is y, -2 and -1. Now, whenever we multiply matrices, I always think of RC Cola. Pretty good drink if you've ever seen it. I like it because RC stands for row and column. Row and column. So in other words, when I multiply things, I take the first row times the first column. So that would be -1 times -2 plus 0 times -1. So that'd be 2 plus 0, which is a 2. There's our answer. Not too bad. Okay, question number 40. No matter how you draw these two lines, no graph in one of these categories has a vertical line of symmetry. Now, a line of symmetry, if we think about a square, for example, a line of symmetry is something that divides it exactly in half, right? So a square does have one. A line has one also, right? So if here's our line, if this is our line, and I were to draw a line of symmetry, vertical line of symmetry on top of that, it does work. Pentagon, 1, 2, 3, there's 5 sides, vertical line of symmetry. Boy, parallelogram. We might think that could be it, right? Like, man, that can't be. But you got to remember, a rectangle is also a parallelogram, right? Because aren't opposite sides parallel? So vertical line right there. Now, a scalene triangle, that's where no sides are equal, right? That's the one we want. Doesn't work out. So the big distractor, I think, was J and F. Seems like people are pretty much evenly split on this. Question number 41 says this equation has 2 solutions. What's the greater of the 2 solutions? Well, to solve a quadratic, we've always got to get it equal to 0. And you could try factoring on this, but I don't believe ACT would want you to factor. I think ACT really would want you to use your calculator. I'm going to graph it. So I'm going to press y equals. We've got 24x squared plus 2x minus 15. And when I graph it, I have 2 answers here, right? I can see that. I can go ahead and find out what they are. Now, the question did say the greater of the 2, right? So I'm just concerned with whichever answer is the biggest. So I'm going to calculate a 0. And if you've ever done this before, it's really not too bad. What you do is you use the arrow keys and move this cursor around. We think the 0 is here. So I got to click somewhere to the left of it and then press enter. And then I got to go past that 0 and press enter. And then I got to go like where I think the answer might be and press a guess. And notice it says the answer is 0.75. So again, our graph was like this, and this number was at 0.75. That's the biggest answer because this one would have been negative. And so we must have A. Not too bad. I think the people that chose B were estimating it and didn't really know how to graph it or calculate it, or tried factoring and made a mistake. Okay, question number 42. Which of the following expressions is equal to this? there's, if you take pre-calculus, there's a, I mean, the answer is this. It says there's a really nice, no, it's J, sorry. There's a really nice, it's called sum and difference properties, but many people don't know that, right? Like, I'm not in pre-calculus. How would I do this? Well, what you would do is you would go ahead and just type it into your calculator. Make sure you are in degrees, right? Like I am in degrees, and I'm just going to type this in. So it's the sine of 60 times the cosine of 30 plus the cosine of 60 times the sine of 30. I get an answer, that's 1, okay? So I'm looking for which one of these gives me an answer of 1. Now, if you know the sum and difference one, or if you know your special triangles, you can work this out, right? So instead of figuring out typing this in, I'm just going to do cosine of 30, right? Because isn't 60 minus 30 equal to 30? So let's see, cosine of 30, nope. The next one, when I add them up, is 90. So the cosine of 90, nope, that's not a 1. Let's try the sine of the next one, letter H, the sine of 30, nope. Let's try one below that, the sine of 90. Yep, that's it. That's what I would do. I would not spend a lot of time on this question trying to think of stuff. Don't overthink it. Just use your calculator. Okay, question number 43. What's the area if the circumference is 12? So we have to remember that area is pi r squared, right? And in a circle, the circumference is how far it is all the way around, right? We're told it's 12 pi. And hopefully we remember the formula for the circumference. There's 2 of them. There's 2r pi. There's also diameter times pi. Doesn't matter which one you pick. Let's say I chose this one out. I'll plug that in for circumference. Cancel out the pi's, and I know that the diameter is 12, so the radius must be 6, right? If I had done this one instead, 12 pi equals 2r pi, cancel out the pi's, divide both sides by 2, we still get 6. Don't fall for it though, 18% of people did. Radius is 6, plug it in. So it'll be pi times 36, which is choice D. Be careful. Okay, question number 44 was, I think, a toughie. It was a bit of a stinker here. The question wants to know how many liters of pure solvent should Lee add? We're trying to create a 50-50 mixture, 50% solvent, 50% water. We are told with 25 liters of solvent, of mixture, 40% of it is solvent, right? So if I were to do 0.40 times 25, that would mean we would have a total of 10 liters of solvent. Now, if there's 25 liters total, there probably is 15 liters of the water. We're trying to make this 50-50, right? So I think we need to add 5 liters of solvent. That way those come up even. Choice G. Not too bad. Okay, 45 was a big algebra problem. Now, whenever we're adding fractions, the denominators need to be the same, like 1/2, like 1/12 plus 7/12, right? The denominators need to be the same. And if they're not the same, like let's say we have 1/4 plus 2/3, well, we got to find a common denominator, which in this case would be 12, right? And so what we do is we multiply the first equation by one number, multiply the second part by another number to get the denominators both to be the same. In this case, we want to have the denominator to be x plus y times x minus y. If we do that, there's our x, right? We're going to multiply the top problem, or the left side, right? This part by x minus y over x minus y, because I think you could see that the x minus y's would cancel getting back to the original, right? So we can do this, that's okay. And I think we'll multiply the other problem by x plus y, right? Over x plus y. All right, let's do this. We'll have, now we're adding here, right? We'll have x squared minus xy plus yx plus y squared over x plus y times x minus y. Now, I think you'll agree with me that these two pieces cancel, and we're left with x squared plus y squared over x plus y and x minus y. Well, I'm looking at the numerator. This is the only one with it in. It's got to be choice E. And in fact, if we multiply out the denominator, we'll have x squared minus y squared. But we really didn't need it. We really just had to pay attention to that numerator to get there. Okay, that one you kind of really see, you know, algebra 2, college algebra, pre-calculus, that kind of thing. Okay, 46. I thought this one was tough, but people, 25% of people got it right. So maybe it was okay. We got 3 people, right? Now we are told that Mary sold twice as many as Carlos did. So Carlos, I'm not sure how many he sold, but we know that Mary sold twice as many. So I'm going to say 2x. So if Carlos sold x, Mary sold twice as many. And then we're also told that James sold 3 times as many as Mary. So James, he sold 3 times as many as Mary. So he should be 6x. What fraction did Carlos sell? Well, if we add these up, we get a total of 9x, right? Well, Carlos sold x of them. So what's x over 9x? I think those x's cancel, and we have 1/9. Choice F. Okay, question number 47. I really wish people did better on this one. I think people did poorly because it was towards the end of the test. This is one of the first videos that we've done. If you don't understand this one, go earlier to like the first couple of weeks of the ACT prep videos. Did a lot of stuff dealing with counting here. So we have 3 spots to fill. And so what I do is I say, draw 3 spots. And there are 6 plants to choose from, and each a different one. Well, how many ways could I put a plant here? Well, there's 6 different plants that could go in the first spot. And there's only 5 different plants that could go in the next one, right? Because there's already a plant in that first spot, and then 4 for here. Multiply those, we get choice D, 120. Okay, again, hopefully people didn't do well on this because it was towards the end of the test, but we've done this one earlier, right? Usually this question lands in the beginning of the test. Okay, 48. I think 48 is a bit of a stinker because the axes are not labeled in numbers. They're labeled in the letters A and B. This question wants to know what's the area of that triangle? What's the area of this triangle here? Well, we know that area is 1/2 length times width. Now the length is this distance. Now, if we look at this, it looks like it's counting by A's, 1A, 2A, 3A, 4A, 5A, and this is counting by B's, right? So I can look at this. This is 1, 2, 3, 4. 4A is the length. And then, well, I guess some people call it base times height, I guess is what it would be a better one to call it. That's the base. The height is up and down. So 1, 2, 3, 4, 5. 5 B's. We get 20 AB times a half, which would be 10 AB, which is choice G. Again, I think this one was rough that it's not, the grid's counting by different stuff. Okay. Let's look at this one. Point M remains fixed. So M stays here. It does not move. But point Q will move to the right along the x-axis. So this point Q is moving to the right along the x-axis. So I could think about, like, we've got a line like this, and then we got a line like this, and a line like this. So, you know, that point Q is moving along the x-axis. Which statement describes what happens to the slope? Well, let's see. I think the slope of all these lines, no matter what, is always negative, right? It's definitely not staying the same. Part B says never be negative. No. Eventually be negative. I think all of these are always negative, so not A. Here, this one says eventually be positive. I don't think this line is ever going to be a positive slope. I think it's always going to be a negative slope. So choice D. It will increase, right? We're at, like, you know, pretty good negative number there. But we're getting smaller and we're getting closer and closer to 0. But it will never be positive. I really thought this one was a bit of a stinker. Okay, 50. Which of these is equal to this? Now this is function notation, right? So we're trying to find out the value of this function when the input is 5a. Well, 5a is right here, right? So if I were to trace that up, we intercept it right here. That spot is f of 5a. There's function f, right? Let's go over what's the answer. 8b. Okay. It's got to be that people are running out of time. So one of the practice things to do is to put yourself on a clock and do timing on this, right? Time yourself. You'll do better, okay? You got to get used to that pace. Okay, 51. Wow, look at this thing. They need 12 jurors for a trial. Now it says these 12 jurors are selected from a jury pool of 60. So the pool is 60, and of those 60, they'll pick 12 of them. Now the records show, that only 40% of the people who are summoned actually appear. So of the people summoned, only 40% appear. Wow. And then of the people that appear, a third are excused. So a third of them are excused. How many should they summon, right? So we know how many should we summon to make sure we have 60 at the end. Well, if 1/3 are excused, I think 2/3 go in the pool, right? So I got to think of 2/3 of what number is 60. And the number that comes to mind is 90. 2/3 of 90, 60. We use our calculator for that. Now, if 90 appear, a third of that is 30, right? So far, we've got a total of 90 people. Safely eliminate this. In fact, I think the people that chose A didn't even read the question, because we're told we want 60 people. So we have to have way more than 60. So definitely not A. They were just guessing here. Now, 40% of the people that summoned appear, right? So I got to think 40% of what number, 0.4 of what number is equal to 90? Well, if I solve that, I wind up with 225, and that's our answer, choice D. This was a tough one. I'll give it to you. That was a tough one. Okay. We've done this one before a couple times. It's going to appear on the ACT for sure. Okay. And it says, what is the 275th digit after the decimal point in this? So in other words, this goes 0.6295, 6295, 6295 forever, right? They want to know what is in the 275th decimal point. And there's no way that you actually write it out. But we know there's these groupings of 4, right? So if I took 275 and divided by 4, I'm going to wind up with 68.75. Now, 0.75 as a fraction is 3/4. So in other words, there's going to be 68 of these complete 6295s, 68 of them. And then there's going to be 3/4 of the next one. Well, lucky for us, there's 4 pieces and 3 of them would be here. So the last digits would be 629, which is the 9. People that got that, congratulations. Okay, 53. Composite functions. This is something we do in Algebra 1, Algebra 2, pre-calculus, college algebra, so on down the line. So let's change g of x to be what it is. G of x is this, x plus 3. So I got to take x plus 3 and plug it into function f. Here's function f. So the x plus 3, that's what goes here. And they want to find out, when does this thing equal 0? Now, I am not going to do algebra to solve this thing. I'm going to use my calculator and graph this. X plus 3 quantity squared minus 4. So I'm going to go to y equals. I'm just going to type it in. X plus 3 quantity squared minus 4. And graph it. And I can tell that it touches at 2 places, -1, and see, -2, -3, -4, -5. So -1 and -5. There it is. You also, if you have a calculator there and you need one, okay, and it's ACT, you need one, you can also get it by plugging numbers in, right? Like I could plug a -5 in for the x and see if we do get a 0 answer. So that's the stuff you want to think about. Okay, 54, we need to use a technique, okay? We're told 2 things. P is positive and N is negative. And we're also told this. What we're going to do is we're going to pick a number for P and a number for N. It doesn't matter what we pick, but try to avoid, I always avoid picking the number 1, okay? But if P is a positive number, so P could be 2, 3, 4, 5, 6, 7, I just got to make sure that its absolute value is bigger than the absolute value of N. So I'm going to let P equal 3. Now, N is a negative number, so I'll let P or N be -2, and sure enough, the absolute value of 3 is greater than the absolute value of -2. So we've got the 2 good numbers. And what I do is just plug them in. So this would be 3 plus 2. We're trying to find the greatest value. So 3 plus 2 over 3. That's going to be 1 2/5. This one would be 3 minus 2 over 2, or negative 2 rather, and that's going to be 2.5. So see what I'm doing? I'm just kind of plugging in the numbers and seeing. This would be, this one here would be 3 plus a negative 2 over 3 plus 2, because of the two negatives there. And that winds up being 1/5. So far I'm like, no. So far this is our biggest answer, right? And it's looking like that's the answer we're going to have. On here, let's try that one. So 3 plus a negative 2 all over 3. When I do that, I get 1/3. Yep, that's not bigger than 2.5. And let's try this last one. 3 plus a negative 2 over negative 2. The absolute value of that is equal to 1/2. Yep, not it. It's got to be G. But that's the way I would go about this one. It's pretty good technique. It works all the time, especially when you get stuck and you really can't seem to think of what's the algebra I need to do on this one. Okay, i's. We're told that I is equal to the square root of -1. If I were to square both sides, the square root goes away and I would have that. If I were to square both sides again, I'd have +1, right? Because -1 squared is +1. Now this I to the third, if we think about it, that's really I squared times I. So it's really -I is what it is. I'm going to plug all those numbers in for this. I plus, now I squared is -1. I to the third is -I. I to the third is -I. I to the fourth is 1. I to the fifth is kind of interesting. If I to the fourth is that, I to the fifth, that would be I to the fourth times I to the first, and I to the fourth is 1, so it would just be an I. It's kind of interesting there. Well, i's cancel here, the i's cancel here. We're left with -1 over +1, which is b, -1. You see imaginaries in Algebra 2. That's the first time you see them. And you see them in all your math classes after that. Okay. Shading, system of equations. Well, let's look at this one first, okay? I think we would agree that's going to be a solid line, which means we could eliminate G, right? Because G has a dashed line. And if I were to solve for the y would be less than or equal to -1/2 x plus 3. That tells me I've got a negative slope. Oh, this line's got a positive slope, doesn't it? Nope. And we're less than, so the shading is always below the line. Can't be here. So just kind of thinking about it, we get it down to there. And now our question becomes, is it F or is it K? Both of those have shading outside of the circles and below the line. Well, the y-intercept is a 3, right? So if I think about this one, that's at a 3, and this point here is at a 3. So the question is 3 inside the circle or outside the circle? It's a great problem. Let me take this problem and kind of get it a little bit nicer. 3x squared plus 3y squared is greater than 12. If we divide by 3, we get x squared plus y squared is greater than 4. So remember, we did a circle one earlier. X squared plus y squared equals r squared. So the radius isn't 4, the radius is 2. So if this is at 3, the radius has 2. It's smaller than 3. It's got to be letter K. That's pretty interesting. But elimination stuff gets us down at least to the F and the K. But again, it's towards the end of the test, right? So you're probably kind of running out of time there. 57. This one's pretty cool. On 57, we're told that A times C is 1, BC divided by D is undefined, and this is positive. Which defined must be true? Well, if this is undefined, that means that the letter D must equal 0, right? Because undefined means divided by 0. So that means this, A, B, C, is how to be equal to 0. Now, if that equals 0, one of those letters has to be a 0, has to be. But if I look over here, A times C is equal to 1. That means A cannot equal 0, and B cannot, or C rather, cannot equal 0. Because how are you going to get 1 if you times them, right? Well, that means that the letter B must equal 0. That's the only choice. Kind of cool. Okay, 58. We're graphing trig stuff. You see this in Algebra 2 for the first time. First of all, the number in front is the amplitude. It's like, how tall is this wave? That wave gets to a height of 3. So I can safely eliminate those two choices. Now, the next part is tough. This is a toughie. So cosine, okay, let's draw this better. Cosine has a complete wave within 2 pi, a complete wave. Notice this is pi over 2, so this is pi. So 2 pi would be out here. Now there's a complete wave right here. And if I put a second one in, we'd have 2 waves in there. That's what the 2 tells you. How many of these waves do you have within 2 pi? Normally there's just 1. So we would have said 3 cosine of x. But in this case, there's 2 of them. And that's why that's a 2. 59. We have to figure out the length of the string. We have to figure out how long this is. Now, there are some things we can do, right? We can think about things being drawn to scale. So if I were to, whoops, didn't mean to get so far back there. Oh, I'm sorry, we're trying to find the string, right? So I could, take this and say, like, how long is that? Doing my measuring idea. And I think it's way easier on paper, right? And we know that this length here, let me get that a little bit better. This length is exactly 240, right? So if I look at the string, let's see if it's bigger than 240 or less than that. Looks like it's going to be less than 240, right? So I can definitely get rid of this one. As far as how less, not sure. So we have to use this thing called law of sines, law of cosines. And I'm going to do law of sines on this. Let's write in some things. If this angle is 75 and the other one's 45, I think this one up here has to be 60. Now, the law of sines says the following. If I have a triangle like this, and it's A, B, C, and then side A is here, and side B is here, and side C. It's like they're opposite the letters, right? The law of sines says this. And the way to know that we have to do law of sines is you got to find a winning pair. You've got to find an angle and the side opposite it that you know. If you don't know a pair like that, can't do it. Now, this is x, right? Whoops. This is x. So I'm going to say that the sine of 60 over 240, right? That's these two. That's got to equal the sine of 45 over x. And now we just need to solve it out. Well, I cross multiply first, right? And then I divide by 60. Okay, I use my calculator, so let's go ahead and do that. Let's see, alpha y equals 240 sine of 45 all over 60. All right, we get a decimal, 2.828. Let me write it up here. 2.828. I think we can safely say it's not those, right? Now to figure out which one it is, we know it's got to be B because that's what I'm telling you. Let's use the calculator one more time. And let's see what that is. 80 square root of 6, right? Let's see if it is our decimal. 80 square root of 6 is that what? About 60 square root of 3. Not that one either. Let's see if I did this one wrong here. 240 times the sine of 45. Right, sine of 60, 240, sine of. Okay. And when I calculate that out again, well, it doesn't seem like that could be right. I'm in degrees. Shouldn't matter that I don't have a time sign in. Yeah, it shouldn't matter. Boy, work this out. I just kind of didn't pay attention on this. Is my angle really 60? See, this is funny. You can watch me struggle a little bit. Yeah, the angle is 60. So let's see, the sine of 60 over 240 is equal to sine of 45 over x. Oh, geez. Sine of 60, right? We got to divide by the sine of 60. That's stupid. All right, let's see if I can do this correctly now. So it should be the sine of 60. And we get 195.959. So we get 195.9. Okay, now if I go back, and I think I've already typed in our decimals for this stuff. There it is. 80 root 60 is exactly 195.959. Boy, that was a good one, Pat. All right, that's what you get for doing videos at 10:30 at night. Okay, number 60. Thought this one was interesting. I kind of fell for it a little bit. As a publisher charges $15 for first copy and $12 for each additional copy. So if I think about like a table of values, right? X is the number of copies and Y is like what we sell them for. So if I have one copy, they're going to charge us 15 bucks. If I have two copies, they keep charging us $12 more, right? So if I were to add 12 to that, that would be 27. 3 copies, I add another 12 to that, I get 39 and so on. I think you can see the rate of change is going to be 12, which gets rid of those 3 choices here. Now, many people did what I did, and they fell for letter G. I thought it was letter G for a second. See, if we backtrack this, remember, we keep adding 12 each time. When x is 0, 3. A lot of people are starting with 1. Remember the y-intercept, right? The y-intercept of a graph is when the x value is 0. Right, that's what that is. The x value is 0 there. So I need to know when x is a 0. Well, hope you guys found this interesting, and keep working on your practice, okay?